Hello there, my name is Evie, and I am making this video to help you learn music theory. In this first review video, we will be covering the properties of sound. Yay! Now, most of you watching this probably can hear, because you're probably music majors or minors, which kind of requires hearing most of the time. Anyway, since you can hear, you know what sound is. But do you really know the components of sound, how sound works, all that kind of stuff? Well, that's what I'm here today to review with you. So, the first thing I'm going to talk about sound with you is the components of tone. P. Diddy. You're like, what the heck does the rapper P. Diddy have to do with the components of tone? I will explain. P. Diddy is an acronym I like to use to remember the 4 components of tone. So, the rapper's name, P. Diddy, spelled like P. D. T, means absolutely nothing to music theory. But, if you spell it like this, P. D. T. This will make a lot more sense. Pitch, duration, excuse my handwriting, intensity, and timbre. Timbre. No, it's not timbre, it's timbre. Okay, so those are the 4 components of tone. P. Diddy, pitch, duration, intensity, and timbre. Now, what are all of those? Let us start with pitch. Pitch is the frequency that a sound wave is traveling at. If something has a higher pitch, like this, your sound wave is going to look like this. Got it? If something has a lower pitch, your sound wave is going to look like this. A good way to think of this is that this is moving faster. So when something like when they chipmunk a video, they speed it up, if that'll help you remember that at all. Another way that I help remember like frequency is if you divide this into even sections-ish, you'll see that there are more little squiggles here than here. It happens more often in a given period of time. So like, I come here frequently. I come here a certain number of times in this span of time. I come here 5 times per day, whereas I don't come here frequently. I have a lower frequency. I come here once every 2 weeks. It's also known as cycles per second, so this has more cycles per second, or hertz. A good way to remember the word hertz is like if you're riding a bicycle, the more cycles per second you make, the more it's gonna hurt. Punny! Alrighty. Now, one thing that I found in y'all's theory textbook is that it's important to know the frequency 440 hertz, because that's the A above middle C, and that's what an orchestra tunes to. Yay! A way that I've come up with to remember that is that the 400 meter race in track used to be called the 440 yard back in the day before the metric system, and it's definitely the most painful race there is. So, the 440 hertz. Puns. I love me some puns. Alright, the next property of tone we're going to cover is duration. So, duration is how long a tone lasts, whether it is short or if it is long. So, in the word duration, we have this Latin root dur. We see it in words like endure or durable. Alright, dur is this little root word thing that means lasts. So it has to do with how long a note lasts. Like how a whole note's longer than a half note in the same time signature and tempo. So duration it's pretty self-explanatory. The next thing I need to cover is intensity. Intensity is also known as dynamics. It's how loud or soft something is. So, a big deal with intensity is amplitude. We're going back to the sound waves here. So, a sound wave that looks like this would be much softer than a sound wave that looks like this. Okay? This was kind of messy. I'm going to draw it a little bit neater and more even. Okay, there we go. So, this is the amplitude. This wave has a larger amplitude. See, this right here, this line measures from the trough to the peak of the wave. Whereas with this, that line is a lot shorter. That makes it a lot smaller. Alright, so a way to remember that amplitude is related to loudness or softness is because when you want your electric guitar to be louder, you plug it into an amp. We're going back to the root words here. Amplifier. Amplitude. Amp. Got it? Yay! Amps. Okie dokie. And the last thing we are going to cover here is timbre. Timbre. Not timbre. It's not timbre, although that's kind of a cool sounding word. But it's timbre. I don't know why they say it timbre, but they do. Okay, so timbre has to do with what makes my voice sound different from someone else's voice, which sounds different from a clarinet, which sounds different from a piano, which sounds different from a cello, which sounds different from a French horn. You know, they may be playing the exact same pitch, at the exact same frequency, at the exact same intensity, but they sound different. So, that's what timbre has to do with. I don't know if Dr. Walker went over with you guys at all what makes different timbres. That has to do with the shape of the sound wave. So we have sound waves that are square waves or sawtooth waves and things of that sort. And that's what makes timbre different. But I think all you guys need to know is that timbre is the different sounds between different types of instruments. Hopefully that's sufficient. The last thing I want to cover is the harmonic series. The harmonic series is what's known as overtones or harmonics or partials, which are pitches that also occur when a certain other pitch is played. There really aren't many what are called pure pitches, which is just like a pitch at, let's just pick A above middle C, 440 hertz. There aren't many instruments that create sounds that are only made with that one frequency. That's the main frequency you hear when you play A above middle C, but that's not the only one you hear. So I actually picked a different note than A above middle C on my little chart that I made. I picked middle C. In this example, middle C is what is known as the fundamental. Now, when you play middle C on a piano or strum a middle C on a guitar or anything else, there are other notes that occur with middle C, other pitches that occur simultaneously to middle C. We get an octave above middle C, so this C. Above that, we get a fifth, so G, followed by a fourth, followed by a major third, followed by a minor third. So, it keeps going on, but they become more and more minute as you go higher. So if you're really, really listening, you might be able to hear this octave, and you might be able to hear this fifth up here. And if you have really, really good ears, you might be able to hear the fourth, and maybe these ones up here. It's basically endless, the number of different pitches that are created when you create one fundamental pitch. But this is mostly what you need to know. It's super easy to remember. It's 8, 5, 4, 3, minor 3. So if you can just remember 8, that goes down to 5, and then just count down and repeat minor 3. That's really all you need to know with the harmonic series. I hope I didn't leave out some big old thing that's going to make you fail the test because I didn't cover on the harmonic series. But anyway, I hope this video has helped you guys. I hope you feel a little bit more prepared in your theory class. And I hope you have a wonderful evening, day. I don't know when you're watching this. I hope you have a great theory class after this. Great test. I'll see you later. Adios, amigos. Au revoir. Auf Wiedersehen, darling.